So the big picture for this lesson is quadratic inequalities. The first type is inequalities involving x and y, two variable inequalities. So this example is y is greater than or equal to x squared plus 6x plus 10. So what you're going to do, just like graphing a linear inequality, you're going to graph the parabola and shade the half plane that represents the solutions to the inequality. So basically you're going to just graph y equals x squared plus 6x plus 10, and then you're going to shade after that. Now there are several different techniques to graph quadratic functions. I'm actually going to write this in vertex form. So that's going to be y equals x squared plus 6x plus 9 and then plus 1. Why did I separate the plus 9 and the plus 1? This makes a perfect square trinomial. So then I can write y equals x plus 3 quantity squared plus 1, and then I can use my vertex form graphing method. There are other methods you can use. You could try to factor it to write it in intercept form. You can find the x value of the vertex using x equals negative b over 2a. You can start that way, whatever way you like. So the vertex for this is going to be negative 3, 1. So let's plot that point right there. And then I'm going to use the perfect squares pattern. Notice that the graph is opened up because the x squared is positive. So I'm going to go right 1 up 1 from the vertex, and then right 2 from the vertex up 2 squared, which is 4. And then right 3, and then up 9. And then I'm going to reflect these points through the line of symmetry or axis of symmetry. And now I'm ready to graph the parabola. And I'm using a solid line because it's greater than or equal to. If it was just greater than, I would be using a dashed line. Okay, so that's a rough idea anyways. So now we need to figure out the shading. And this is usually the most confusing part. Where do you shade? I like to use a test point. I use 0, 0 because that's usually the easiest coordinate to figure out. So I'm going to put that right in this inequality here. So that makes 0 greater than or equal to 0 squared plus 6 times 0 plus 10. Now if this is a true statement, that means I need to shade outside of the parabola where the 0, 0 coordinate is. If this is false, that means I need to shade inside the parabola area, which is not the half plane containing the 0, 0. So simplify this. 0 greater than or equal to 0 plus 6 times 0, which is 0, and then plus 10. So is 0 greater than or equal to 10? Well, the answer here is no, it's not. So that means this half plane outside the parabola is the false area, and I want to shade the true area, which is right here. So that shaded area represents all the solutions to this inequality. Y is greater than x squared plus 6x plus 10. So that's how you do that type. Okay. Now there's also a single variable quadratic inequality that looks like this. X squared plus 5x plus 6. Let's say that's less than 0. So we need to solve this guy. Still going to start by making a graph, or at least a sketch of one. This factors to x plus 2 times x plus 3 less than 0. So I'm going to graph y equals x plus 2 times x plus 3. And then I'm going to use that graph to determine my solutions for the inequality. So let me plot the zeros. There's one at negative 2 and one at negative 3. And the parabola is opened up. I'm just doing a very rough sketch here. That's all that's needed. So the question is, when is this parabola less than 0? And 0 meaning y equals 0. So that's where the parabola is below the x-axis. And that's between negative 2 and negative 3. So my solution is x is going to be greater than negative 3, less than negative 2. That is the interval where the parabola is below the x-axis. So that means it's less than 0. And it's not equal to because this is not equal to. So that's the big picture for this lesson.